Okay, so we are on page 81. If we read the given question, it says that you have an incomplete front view and the top view of a right regular hexagonal prism that has been shaped to fit around a right regular square prism. The axes of both prisms lie in a common vertical plane, and that just means that the two centers of the prisms align. Okay, then you have the position of point S on the drawing sheet. You have to draw the given to complete the front view, clearly showing the curve of interpenetration, and then you have to develop the surface of both prisms, and you need to show all necessary construction and fold lines. So now we are going to start off at point S, so you know that when you get a square, you halve the length of one of the sides, and that will give you the radius for the circle that you're going to draw the square around. So this will be 19. And the circle should be in construction. Then, to just make sure that your edges of your square goes where they are supposed to, you need to just get construction for the center. You can do center lines as well. Okay, and then the square is lying on one of its corners. That means that the sides will be on a 45-degree angle, and they have to touch the edges of the circle. Okay, so now we need to get the branch surface, okay, and then before we can do this, we need to get an auxiliary view, and we'll have to first move to the front view before we can complete the top view, okay. So basically what you're going to do is you're going to just inline here, you're going to draw your hexagon. So I just want to get the hexagon's dimension. Remember, if you want to draw a hexagon from a center point, it is a circle that is the same radius as one of the sides. And I only have to do a half a hexagon. I don't have to do the full one. So I'm literally just going to do half a hexagon. I'm not going to do the full one. It just saves some time. Even though they show the full one, the half will be accepted here. Okay, sorry, so the hexagon is an inscribed, not a circumscribed. So it's inside the circle. Just want to get my center point properly here. And I'm going to extend my center here. Okay, and then my compass is on 22. Just make sure that it didn't move. Yes. Okay, so from the edges here, I'm just going to scribe on both sides to get my flat side here. And this is an auxiliary view, so it is in a B type of line. And then you will see when you're going to draw your sides, it will be on a 30-degree angle. 30-degree angle. Okay. Okay, so now I'm going to project these four corners so that it touches my main surface. Okay, so I have that, and now I'm going to go to my front view. So I'm done with that. So I want to go to my front view now. I'm going to just project all corners of my square. I will get an XY axis. And I will get the base of my front surface. Then I will measure my height of my front surface, which is 72. Okay, and now when you look at this here, if this would have been aligned, you would see there would be a construction line there. You'll see with some of the other drawings, they show it to you like that. So here, they are not aligned, so we need to work from the bottom where they give us the dimension, because sometimes they won't give you the dimension of this, but they will show you that the branch surface aligns with the top of the main surface. Okay, and then here I can see that I will see this corner. So this corner here on my front view will be an A type of line. Then I'm going to now start and work on my front view for my branch surface. And they say that it is 18 millimeters from the bottom, where it then starts on a 30-degree angle. Okay, and then the distance that I now need to use here is from my auxiliary view. So on my auxiliary view, I'm going to create a reference line for the distance that I want, which is basically just creating a little corner here, and I'm going to scribe that distance twice. Because remember now, this is not a true length, okay? So I'm going to scribe it twice. I don't exactly know where, but I'm going to scribe it on the angle. Okay? On the angle, just so that I know where it's going to be. And then I'm going to measure my length here, which is 36. From my base, 36. And obviously now, opposite of 30 degrees is 60 degrees. So here I can see it meets my scribe. Okay, I just want to check this again. Sorry. Okay, and then I'm going to, from those scribes, just draw construction inwards. This one will be solid up to there. This one will also be solid up to there. I know that for a fact. Okay, and then I'm going to just close my branch surface and close my main surface here on the sides. So now, if I'm done with that, this is now basically the given views that they've given us for the front view, and we're going to be able now to complete the top view by projecting these points down. And then I can go and I can draw in my hexagon the way that I can see it here. Okay, so those are the given views completed. Okay, so now for the curve of penetration, I need to see where my branch solid touches my main solid. So the first thing that I'm going to do is I'm going to do numbering. So remember I said never ever number where the branch surface penetrates into the main surface, okay? So don't do that. So I'm going to start on this side. And then I'm going to label here as well. That doesn't matter. Okay, and I'm going to transfer my numbering. So 1 is here, 2, 3, 4. And then also transfer my numbering for my branch surface. So 1, 2, 3, 4, 5, and 6. Okay, so you see I number in like as if I'm going around here, okay? So that's how you should be numbering. You just start at 1 and then you go in the same direction. So I went clockwise here, you go clockwise there. Okay, does that make sense? Okay, so now for the curve of penetration, I'm going to project. You'll see that these points align. Okay, sorry. Let's check here. Okay, so project. And project. Okay, so there's my projection. Sorry, that is skewed. Okay, then I'm going to, on my 30-degree angle, project these points inwards. Okay, so now 2 and 3 only goes up to this projection, that one there. Okay, as well as 5 and 6. Only goes up to that projection. And then here, numbers 1 and numbers 4 goes up to this projection there. Okay, so that is my curve of penetration. I will connect those dots or points. Okay, so now my curve of penetration is done. I've done the given top view. I've completed the curve of penetration. They want us to develop both surfaces. So now I have a lot of space here. I only have 4 sides for my main surface. So what I'm going to do is I'm going to project the bottom and the top of my main surface across. Okay, I'm going to get a starting point. This is 1, okay? So now, from a true length, so top view is my true length for the distance of my branch surface. I'm going to scribe it. How many times? 4 times, because I have 4 sides. Okay? 1, 2, 3, 4. Project in construction. Label 4, and remember to go back to 1 when you do your labeling. Now I want to find my curve of penetration. So I have a few points that I need to project. We have this point here at the bottom. We have this point here, so that don't forget about that one. We have that point, this point, and that point, okay? So we don't only have the actual curve, but where the branch solid touches the main solid, you must also project those points across. So now it falls on point number 3, so I'm working on point number 3 here. Now, there and there, those points will be actual points. So on point number 3, because that is where they touch here, okay? Now I need to go and use true lengths, okay? So from my top view, to see how far does number 6 and number 5 go into my solid, okay? So number 6 and number 5 is right here. So there's number 6 and number 5. So that's now this point. I've gotten that point. I want this point. Number 6 and number 5, okay? Then the same distance will be for numbers 2 and number 3. So number 2 and number 3 is here. So there's number 2 and number 3. And you see I'm working from number 3 here, okay? So from number 3, from my main solid. Then I want to find numbers 1 and number 4. So they will be the same there, okay? And they are on the middle line here. See, there's number 1 and number 4. So it's that point following your projection, okay? Sorry, I just want to check here. Right there on the edge and right there on the edge. Okay, so now I can go and I can draw in my hole of penetration. You'll see it kind of looks like a type of a heart. Okay, so we're just gonna then do the other half here. Okay, so now this is the hole of penetration. So you guys see it doesn't really look like a hexagon, and that is because it's on an angle, okay? So that is the reason for this. Okay, then I'm just going to do my solid lines for my corners. And then here I will skip the hole. Okay, now I want to do the branch pipes development. Now this is quite easy because I have a lot of space left that I can work with. So just somewhere there you're going to get your base straight. Okay, just before we do that, don't forget to label, and they call it a surface. Okay, so this will be the main surface. Okay, so that's the main surface development. Then for the branch surface development, again, remember we must use a true length, and this will be the true length. Now, you can either use that or you can use the auxiliary. It stays the same thing. Okay, so from the edge here, I'm going to scribe now how many times? 6, because we have a hexagon. Okay, 6, and then I'm just going to project my lines up. Doesn't matter the distance, just long enough for where for the branch development. And then I'm going to label it. And when we get to 6, we go back to 1. Okay, now, true lengths. Okay, so I'm first going to do the ones that I already have. So you can either use your front view, or you can use, okay, no, sorry, you have to use your front view, because that is the actual true length. Okay, you guys see here, that's not a true length, no? Because it's on its side. Okay, so we must use the front view here to get the actual true length. Okay, so that will be 1, as well as number 4, and then back to number 1. Then I'm going to do 5 and 6. And I'll do 2 and 3. Okay, now remember that this is a square, so we need to get this distance as well. Okay, so we'll use from 6 to number 3, and this we will do somewhere here in the middle. Just do a large scribe, and then the same here from 2 and 3 to this number 3 of the main, and then somewhere here in the middle we'll just do a scribe, and then we just need to find the middle of the 22. So I can just go and measure 11. And why am I saying 22? Because the side here is 22. And then I'll just get my center there, get my center here. And these will be fold lines. These two will be fold lines, and the rest will be solid lines. Okay, and that is now my branch surface development. Okay, and that is then how it would look like at the end.